Hi and welcome back to a new video. Today's topic will be about the RTX 5090 again. It will be about the Founders Edition and the question if we can water cool this card with a custom water cooling block. We already finished our prototype, milled them downstairs, and they're currently still vacuum sealed simply because we want to avoid any kind of oxidation on the copper parts, and it's a little bit easier for me to handle it. The general question will be how easy it will be to disassemble the card and to mount a water block. That is probably the only question. I mean, it's out of question that you can definitely water cool this card. But the question for us as Thermal Grizzly is, how easy is this? And is it on an okay level that we design something like it and the customer has to disassemble this card and then assemble it again on the water block? There are a lot of voices out there that are saying that this is way too complicated and something a normal customer shouldn't do. Then again, if I just look back at my own water cooling history, I water cooled cards such as a 7950 GX2 or a 9800 GX2 from NVIDIA. And those were also very complicated cards in terms of how they were built, like multiple PCBs, even like small ribbon cables in between. And it was also possible to water cool them. It was not easy to assemble or disassemble these, but it was possible. And that's the question for today's video. Hetzner is Europe's leading hosting provider and data center operator with hundreds of thousands of servers. Its innovative in-house server design, great prices and excellent support make Hetzner the perfect partner. With its own data centers in Nuremberg, Falkenstein and Helsinki, Finland, you get powerful dedicated servers, S3 compatible object storage or high-performance cloud servers at a low price, depending on your needs. And you also get extremely affordable high-performance VPS options which are available in the US and Singapore in addition to the data centers in Europe. Click on the link below to explore Hetzner's portfolio. But before we start with the disassembly of the card, we first have to add it back into the system and just get some baseline numbers. Run 3D Mark Speedway in a looped test so we can get baseline temperature for GPU, for the memory under load, and also what kind of clocks we will see. At least that we have some kind of comparison values later on once we have the water block mounted, and then we can see if there is a benefit, and if so, how big the benefit will be. I will first run the Speedway in loop for 15 minutes. After 15 minutes, we can see a GPU temperature closing in on 74 degrees Celsius, memory temperature 90 degrees Celsius. Also on the right, we see the average of the 15 minutes, so that's almost 73 on the GPU and 88.3 on the memory. We can see a GPU power draw that is going between 540 to 570, as you could see. So the average across the 15 minutes is 546 watts, and the GPU clock is somewhere between 2650 and 2670. Average 2655. That is our baseline. Time for the teardown, and it's good for me that both Steve and Tech Power Up already did theirs, so I can just follow their instructions. And I think the first thing to do is to remove the I/O shield. And underneath there is another Torx screw we have to remove. Now we should be able to lift up this frame starting from the PCIe slot. Then proceed to remove these screws that are fixing this triangle where RTX 5090 is written on it. The same thing for the other triangle. For the second triangle, just slide it around this piece right here. You don't need any force for it, so just be gentle. So that's the first PCB. I still like how this card is made. It's really special and looking forward to work with this with the water block. So now we have to get this off. And here we can already spot the second problem, or I would say challenge. That's the ribbon cable that goes all the way to the front for DisplayPort and HDMI. Now for the backplate removal, I think it's nice to use the gap in between the connector and the backplate. You can slide an opening tool, for example, I fixed opener in between, and then just gently release it. We have 4 cables that we have to remove. We have the top right one, bottom left one, which are the same. Then another one on top left and the display connection cable. The top right and the bottom left are fairly easy. So there's a small plastic latch on the back. You can just lift up gently with the fingernail, for example, or if you have some small plastic tool, should look like this. And this other connector, you have to slide the metal piece towards the right. So just like this. It's open and you can see this way closes it again. This connector you just have to lift up. For the display cable, I'm using this thermal paste spatula. Just use anything plastic, be very careful, lift it up gently from the side. Use like an opening tool, for example. And then probably final step, remove 4 screws to remove the PCB. Okay. Honestly, this was not as bad as I expected. It was a bit tricky with the small cables, but apart from that, this was actually quite smooth. Now the thing is, what I couldn't find in the other teardowns is how to remove this cable and get the third PCB out there, because we will need that, otherwise no display signal. I will try to remove the fans first. You can see small screws that are holding down the fan blades, and maybe then I know how to proceed with this. Removing the fans alone and also these screws on the I/O area alone didn't help, but then I noticed some small notches all the way here and also here. And I think there are some tiny metal clips inside that I have to push in, and then I can maybe lift out the heatsink. Turns out it was indeed correct to remove the fans, because we have to bend the clips inwards from the other side. You can see the clip in the center, and we have to take a screwdriver and then access here and bend this inwards. Of course, the fourth clip had to be different, the one that is sitting next to the ribbon cable. We have to push this one inwards from the other side. You can see also a slightly bend the fin of the cooler right here. So you have to go down here really careful with the screwdriver, bend it in a little bit, then you can lift it upwards. So here you can see it again. We have 3 of these clips on one side, and then on the fourth one it's missing, and the fourth clip is on here on the inside. And the 3 clips you just have to bend inwards a little bit to release it from this side, and then the fourth clip you have to go from the top side, but then to push this one in. There we have the cable, also the I/O area, and I have the feeling that NVIDIA glued this in, so I have to be really careful removing this out. So far I would rate this a solid 8 out of 10 in terms of complexity and difficulty for taking it apart. So far also the most complex part was the springs that held the cooler inside and figuring out how to press in from which side to relieve it or release it, especially the one that is close to the display cable. I think that is probably the highest risk, but now I will just heat it up a little bit. That might make it easier to take out the cable with the glue. The easiest is probably to just heat the aluminium from the outside, then until you can't touch it anymore, so that's typically between 60 and 70 degrees Celsius. That might help. I think it's only the bottom piece, and then I should get it out. And you can see the adhesive strip that was on the backside. I also want to find out what kind of liquid metal alloy that NVIDIA is using on here, which can give me more information, more insight about the performance of this specific liquid metal that NVIDIA is using. Theoretically, it's even possible that they might use a thermal grizzly liquid metal. I could tell if it's exactly the same alloy, but I think it's unlikely. It's still possible because we're shipping often huge amounts to other industry partners, and we often don't exactly know on which products they are used on. For this, I will take a small foil and then take off a little bit of liquid metal. And this now goes into our X-ray spectroscopy machine. No worries, I will not leak the exact alloy. I will just analyze it and probably blur the result, because I will also protect if it's something else what they're using. So now we're checking. We're blurring out the indium and gallium amount, but I can tell you that it's about 10% tin, which simply tells us that this is not the highest performing liquid metal alloy that you could get. It is very similar to what we are selling as conductor node, but for example, conductor node extreme wouldn't contain any tin and would perform a little bit better in addition. And as a double check or quick comparison, this is now conductor node. This is very close, extremely close, maybe too close. So maybe that's actually conductor node, interesting. But for now, we have to first remove the liquid metal from the GPU. And for these cases, Kapton tape is extremely helpful. And then simply wrap the entire PCB in Kapton tape. Backside should not be necessary, but everything on the front. Whenever you have a case like this, where you want to clean liquid metal from a GPU, for example, and especially with a gasket like this, I can just recommend doing something like it, because you will just protect everything else and there's almost no more risk involved. So now taking off the gasket, you know, especially in such cases where there's also glue involved and a piece might suddenly come off the gasket, there's always a risk that liquid metal might fly somewhere. Yeah, like now, tiny bit on my thumb. Now, very important, use a wet cloth, ideally with a lot of acetone. Otherwise, if it's dry, you will smear it everywhere. And with this, you should be able to get it off. And here you can see this, exactly what I meant. There's quite some liquid metal on the tape now, which is fine. I just have to be careful removing it, but otherwise this would be stuck to the PCB. Here we have the cleaned GPU. I couldn't find any more liquid metal residues anywhere. Also, the press build imprint on the GPU, which was debated or discussed before. I think there was even a statement by NVIDIA saying that these are still the same as the retail GPUs. A few days later, it's time to assemble the water block, which I already showed earlier in this video, at least some of the parts. And these parts are still just prototyping parts. And if we decide to make this a commercial product, it would not look exactly the same. Like the cover plate on top would not be full copper because it makes it incredibly expensive, and we would try to make it a little bit cheaper than this. So now have to assemble it. One thing that's kind of unique about our water blocks is that they all come with a glass plate. And you might have seen this in one of my previous videos that we bought a water jet cutter, and we just bought this because we wanted to be able to cut glass in-house. Because we want to move away from acrylic or any kind of plastic inside the blocks, which makes the block a lot more durable and also like easier to clean, for example. There's no risk of cracking like what you theoretically might have with acrylic. So yeah, we will first assemble this now. The parts, when we store them internally, are vacuum sealed simply because it prevents them from building an oxide layer and looking ugly even after storing them for a longer time period. That's the main copper cold plate. I think it's made from 14 millimeters of copper, so that's quite a lot of material. That's kind of the downside of using a glass plate, because conventional water blocks, they often also have a part of their cooling channels milled into the acrylic, which we obviously can't do. So we need more copper for everything when it comes to the cooling channels. But I think it's also kind of the beauty of it. I really like it. What's still missing though is the cold plate itself, the one that contains the fins. We decided to go for a modular design. So in theory, for our blocks, we could also offer different cold plates, like even more insane ones that would make the block otherwise more expensive. Here you can also see the matte copper finish that we will offer. Obviously, the retail product will be nickel plated, because otherwise, if you touch this, you will have fingerprints immediately and they will stay. So that's a little bit of a hassle, but you can see there's just a different surface finish, but I think the matte surface makes it look even more beautiful. That's kind of how it will look like. Obviously, a retail product would also have the matte finish inside, but for just testing, this should be fine. I now have to add all the O-rings, assemble everything. I will let Joe, the master, do the assembly of the block, because I mean, he designed it and then he knows better how and where the things should be placed. Also, especially looking at This piece over here, you can see that he first placed tiny little pieces of O-rings, and that would be different if it was mass production. That would just be one piece. And now for a prototype, it's fine to make this out of different smaller pieces. Before I add the cooler into the loop, I want to make sure that it's not leaking. So we're first doing a pressure test. That's not looking good.
That's not quite.
Nope. That means we have to open everything up again. Just double check all the O-rings. Maybe something was not sitting correctly. Everything just took apart, cleaned, put together, and we're now testing again. We're testing with a 0.6 bar. That looks great. That looks really good. We are now finally at the stage that we can add the GPU to the block. You can see it's all done, leak tested, assembled. And I also want to highlight again that this is a prototype. If we decide to go into some kind of production stage, there would still be quite a lot of changes. For example, the PCB for the PCIe that is mounted on the bottom would carry currently most of the weight. And it would not attach to all of the holes. So there would still be some changes to be made to make sure that this is a bit easier to use than it currently is. But let's just proceed and mount everything. Quickly cleaning all the important surfaces. Also cleaning GPU and areas around it. We will not use liquid metal on this for now, because it's probably not even needed on a water cooling setup. That's something we have to test. And also because I have to take it apart again in a second, and I didn't reuse the liquid metal barrier. We're using our new Duronaut thermal paste. Now on the memories and also VRM, all those areas we're using thermal putty, so Putty Pro, simply because we also decreased the gap in between the memory or like any of those surface areas in the memory and the VRM. So a pad, even a 0.5 wouldn't work, but overall with a small gap and putty, we should just reach much better performance than stock. Just forming small pieces with the gloves. And then just putting this on each memory IC. Doesn't have to be perfect or like beautiful. It's just important that the center is covered, like the edge around it. It will squeezed out anyway. It will be squeezed out anyway, and the main part where the heat is coming from is just the center of the chip. Like the actual memory chip is much smaller than what you actually see. Even if this might not look like a good application, this is absolutely fine. Like again, the gap between the memory chips and our cooler on our water blocks will be 0.4 millimeters roughly. That is nothing, almost nothing. So, I mean, this is probably like 2 millimeters height. So this is still plenty of putty. And as long as the center is covered, everything else will just be squeezed to the side and will absolutely do its job. On the VRM, it's a bit more complicated to access, like the small one on here or in between the inductors. So I will just apply the putty onto the block directly. So this edge here, the tiny one here, and these parts. Again, also here, it doesn't have to look absolutely beautiful, it just has to work. We are reusing the original backplate because we need those additional holding points for the screws for the PCIe PCB. We didn't have time to replicate that, so just making use of the original backplate. Now adding the PCIe PCB back, you can see we're only making use of these screws and not of these, which is not that great it would be much better if we had additional support here. That would definitely be a change for a retail product, but for now, for a test, this should work, hopefully. Maybe I should add this one first though, because this goes under the backplate. Moment of truth, you know, even for us, it's prototyping. In between, like we're doing a lot of stuff with the PCB and then assembly. You never know if it now actually works or if we broke something in between. So I'm also sweating a little bit right now to see what the outcome is, if it works. Also, I read a lot of comments about, you know, the Founders Edition PCB being so small and that we would potentially see such small water blocks. But you have to keep in mind that the position, the location of the main PCB is determined and set by the bottom PCIe PCB, which we can't change. Like this would always be the same, unless we would remodel this PCB, which, especially considering that it's PCIe Gen 5 and the problems we have been seeing already, we would not go down that rabbit hole. First test, still without water. I just want to see if I can boot with this thing. Yeah. That looks really good. You might also see that I added a tiny bit of support in between the motherboard and the GPU block, the copper, because I wasn't sure if it's a really good plan to have no support considering how fragile the small PCIe PCB looks. Now if we check in GPU-C, again, this is no load. You can do this for a couple of minutes. You can see we're still below 40 degrees Celsius on the GPU. That looks promising. This type of test without water, it's possible to do this for a couple of minutes. You have to keep in mind, it's a lot of copper on this block and it takes quite some time before it heats up. This is all looking a bit sketchy, difficult, you know, all the force pushing on the card from different edges. Yeah, the fittings, the tubing, the small PCIe PCB. I'm not, too happy about this, but for a quick test, now to see the temperatures and everything, that should be fine. Idle looks already really promising. We have 22 degrees Celsius on the core and 32 on the memory. Just a quick test first, a single 3D Mark Speedway to check the temperature and see what kind of load we have. And then I will repeat 15 minutes if everything is in line, and then we have a comparison value to our stock condition. 3D Mark Speedway passed. We have slightly better performance than stock, at least from my first assumption or first look. And that might be the explanation. The clock is a little bit higher than in the stock condition. Almost flat, 2700. I think that's because the GPU is staying a lot colder. 43 degrees Celsius, 44 under load. That looks really good. Memory 50, 52. That's almost 40 degrees Celsius drop on the memory and like 30 degrees Celsius drop on the GPU temperature. Now after over 20 minutes under load, we can see the GPU temperature is about 50 degrees Celsius, memory temperature about 60 degrees Celsius. That is still an improvement of about 25 degrees Celsius versus the stock condition. And that's also mainly because the water temperature is now over 30 degrees Celsius. Even with the Mora, we're still constantly pumping 530 watts into the water cooling loop, which is just quite a lot. It is still an improvement also on the GPU clock, average 2680 megahertz. 5090 Founders Edition water cooling conclusion. It is difficult, but it's possible. I personally would rate this a solid 8.5 out of 10 in terms of difficulty. But also if I compare this with other cards I did in the past, like a 9800 GX2, that's a long time ago, it's not much different from the difficulty, to be fully honest. The most difficult part in the entire thing to me was getting the main heatsink part out of the frame. And that was mainly because it has two different types of locking mechanisms, how the heatsink is held in the frame. If you spend time on it, if you try to figure it out, if you're being careful, then this is definitely possible. You just have to pay attention how to get this out, not to damage the small ribbon cable that is for HDMI and DisplayPort. That I think is the biggest challenge, getting this out with the tiny bit of glue on the side. But apart from that, it is definitely possible. And I was also positively surprised of how much more the PCIe PCB can take. I thought it would be extremely fragile and like bending it or whatever would instantly break it, because in between 2 or 3 times I thought I would break the card. like hooking these up, the card, it was not on camera, but the card kind of fell out of the slot and I thought that I broke the PCB. But then just plugging it back in, everything was fine. So it's maybe not as fragile as some people might think, and I think it will also come down to how well the water block is designed. In the way it is right now, I would not release it to a normal customer, but with a few tweaks here and there, especially hooking up the bottom PCB more to the block, making it more sturdy, then I think this would definitely work. But we need your feedback. If you would like to see that, especially if you're a 5090 Founders Edition customer, if you're looking for a custom water block, yes or no, we will have a link in the description to the Google Forms where you can just leave us some feedback if we should continue our development work on this or not. And shortly, we will also do more videos with this card, because even though NVIDIA says the Founders Edition is not an overclocking card, that might be true for the stock condition, but it seems like I did a quick test. It's definitely possible. Like, we will also do shunt modding for sure and see how much we can push on this card, but that will be for a different video. I hope you enjoyed this 5090 first time custom water cooling for Founders Edition, but I also think overall, at least I didn't see any other custom water cooling in action so far. See you next time. Bye bye.